Ladies and gentlemen, today we're going to talk about something essential in the world of Python programming: comments. Now, you might be wondering, why are comments such a big deal? Well, let me tell you, they're not just lines of text, they're the secret sauce that makes your code more readable, more understandable, and even safer. So, what exactly are comments? Comments are like the notes you write in the margins of a book to explain the story to yourself or others. In Python, they serve a similar purpose. They are there to explain your code, make it more readable, and even help you when you're testing your code. Creating a comment in Python is easy. Just start a line with a hash symbol, hashtag symbol, and Python will ignore everything after it. Let me show you. Hashtag this is a comment. Print, hello, world. You can also add comments at the end of a line, like this. Python. Copy code. Print, hello, world. Hashtag this is a comment. But comments aren't limited to just explanations. They can also be used to prevent Python from executing a specific line of code. Imagine you want to temporarily disable a line for testing purposes, comments to the rescue. Hashtag this line won't run. Hashtag print, hello, world. Print, cheers, mate. Now, you might be thinking, but Steve, what if I want to leave a comment that spans multiple lines? Good question. Python doesn't have a specific syntax for multi-line comments, but you have a couple of options. You can use the hashtag symbol for each line like this. Hashtag this is a comment. Hashtag written in. Hashtag more than just one line. Print, hello, world. Or, you can be a bit creative and use a multi-line string. Python will ignore it as long as it's not assigned to a variable, effectively turning it into a multi-line comment. This is a comment. Written in. More than just one line. Print, hello, world. So, remember, comments in Python are your best friends when it comes to making your code clear, concise, and easy to work with. Use them wisely, and your code will shine. That's the beauty of Python: simple, powerful, and elegant. Thank you, and happy coding! Ladies and gentlemen, let's talk about something that forms the very backbone of the Python language: keywords. Now, you might be wondering, what are keywords, and why should I care? Well, keywords are the magic words that Python understands, the building blocks of the language, and knowing them is like having the keys to a kingdom of endless possibilities. Keywords in Python are special reserved words that have specific meanings and functions. They are the instructions you give to Python to perform various tasks, like controlling the flow of your program or defining data structures. These words are not to be taken lightly, they are the tools that bring your code to life. Here are some of the most crucial Python keywords. If, this little word helps you make decisions in your code. It's like having a digital Sherlock Holmes, it allows your program to choose between different paths based on conditions. Else, think of else as the trusty sidekick to if. It kicks in when the if condition isn't met, ensuring that your program always has a plan B. For is your Swiss Army knife for looping. It helps you repeat a block of code a specific number of times, or over a sequence of items, like a hero on a mission. While is like the sentinel guarding the fortress. It repeats a block of code as long as a given condition holds true. It's the essence of automation. Def, this one is for creating your own functions, think of them as your custom-made tools to solve specific problems. With def, you become the master craftsman of code. Class is where you create your blueprints for objects. It's like being the architect of your digital world, designing structures that encapsulate data and behavior. Return is the way to give something back. When a function has done its job, return lets you send a result back to the caller. Try is your safety net. It lets you catch and handle exceptions, those unexpected errors that can trip up your code. Except, this is your plan for when things go wrong. Except works hand in hand with try to manage exceptions gracefully. Import is like opening a treasure chest. It allows you to bring in external libraries and modules to supercharge your Python capabilities. From is like a spotlight. It helps you specify exactly what you want from an imported module, making sure you only get what you need. These keywords, my friends, are the commandments of Python. They're the tools in your digital toolbox, the keys to unlocking the potential of this incredible language. And remember, mastering them is not just about knowing their names, it's about understanding how and when to use them to create your own digital masterpieces. So, as you embark on your Python journey, remember these keywords, for they hold the power to turn your code into a work of art, a symphony of logic, and a testament to your creativity. Python is not just a language, it's your canvas, and these keywords are your brushes. Embrace them, use them wisely, and together, we'll create a future where technology knows no bounds. Thank you, and keep coding.
So my next question is, what are basic data types in Python?
In Python, the most basic data types are integers, floats, strings, and booleans. Additionally, Python has some built-in data structures such as list, tuple, and dictionary, which are also considered as data types. For example, integer is a whole number, positive or negative, without decimals, of unlimited length. Float, which includes fraction represented in decimal format. String. There are two ways to represent strings in Python. String is enclosed either with single quotes or double quotes. Both the ways, single or double quotes, are correct depending upon the requirement. Boolean equals true or false. List and tuple are used to store multiple items in a single variable. But tuples are immutable as opposed to lists, which are mutable. Dictionary, written in curly braces, used to store data values in key-value pairs. You can use type function to check the type of a variable. What is list in Python? A list is a collection of items that are ordered and mutable. In other words, a list can store multiple items and you can change the order and values of the items in a list. For example, here is the example of creating list. Square brackets in Python denote a list and elements separated by comma. In list, slicing allows you to grab a portion of the list and indexing allows you to access a specific element in the list. For example, if we want to grab the first three elements, we can use slicing like this: print into bracket list numbers and square bracket 0 index number, separated by colon value 3. The result will be 1, 2, 3. If we want to access the second element, we can use indexing like this: print list underscore numbers 1. The result will be 2. To concatenate two lists, we can simply use the plus operator.
What are the commonly used list methods in Python?
Let's talk about method in list. Append method allows you to add an element at the end of the list. For example, list.append 9. Extend method allows you to add multiple elements to the end of the list. For example, list.extend in bracket list element and square bracket you wanted to add. Insert method allows you to insert an element at a specific index. For example, list.insert in bracket index position separated by value. Pop method allows you to remove an element at the end of the list by default. For example, list.pop bracket. Other methods can be: sort method allows you to sort the elements in ascending order by default. The reverse method allows you to reverse the elements in the list.
What are the arithmetic operators in Python?
In Python, arithmetic operators are used to perform mathematical operations such as addition, subtraction, multiplication, and division. The basic arithmetic operators in Python are: plus sign, addition, which adds two numbers and returns the sum. Minus sign, subtraction, which subtracts one number from another and returns the difference. Star, multiplication, which multiplies two numbers and returns the product. /, division, which divides one number by another and returns the quotient. Ampersand, modulus, which returns the remainder when one number is divided by another. Exponentiation, which returns the result of raising one number to the power of another. /, floor division, divides one number by another and returns the quotient as an integer by removing the decimal part.